All right, welcome to the second video for week 14. This video is optional. This video is optional. This video is optional because we will not have a quiz over this. It will not be necessary on your project unless you draw a shape that is a regular polygon. If you just draw squares, trapezoids, or draw shapes that can be broken into those, you will have no need for this formula. But we do have this formula, and I will go over it just in case. So this scenario covers what if we have and I wish, do I have one? Nope. Okay. I was hoping I had a tool that would make me draw better shapes, but I guess I do not. Okay. If I had man, I'm really bad at this. If I had there we go, a regular pentagon. All right. And I want to find the area of this regular pentagon. I'll need to know just a little bit of information. I need to know some sizes, right? What I need are two pieces of this. All right, I need to know one of the outside pieces, right? Which let's just say this one is 8 inches. And then we need one more piece of this. And that's called the apothem. And that's from the center of the shape to one of the sides in a perpendicular way. So let's write that down. So we have the apothem. All right, and we can kind of think of that as the radius. All right, it goes from the center to a side, center to the side, and is perpendicular to the side. That's the apothem of this shape. And unfortunately, these formulas are not really the most simple. So what we have to do next is to try to think, how can we break this shape down into shapes we do know how to find the formula, the area of. So let's say the apothem here is 7 inches. And we have to know those two pieces of information. So what we can do is, and just like we did for our angle sizes, we can break this pentagon into 5 triangles. And because this is a regular pentagon, each of those triangles are going to be the same size. So if we found the area of just one of them, then we'll know the area of all of them. So that's what our new focus is going to be. And this triangle, which has a height of 7, and a base of 8, we need to find the area, right? So that's easy, right? We can do that right away. The area of that is 1/2 7 times 8. And if we actually calculated that, that would be 3.5 times 8, or 7 times 4, which would be 28. And those would be square inches. And then we would take that and do 5 of those, right? Because we're doing the whole pentagon, not just one of those triangles. So we do 5 times a, in which case that'll be 1/2 times 5 times 7 times 8, which would just be 5 times 28, which would be, I just want to make sure I get this correct, so I'm going to use my calculator. 140 square inches. All right, so that was a nice, clean example. We already had the apothem. But unfortunately, we don't always get that. And the short version of that formula is A is equal to N, which is the number of sides, divided by 2. times the base, or the side, times the apothem. All right. But we have another scenario which makes it a little more complicated. Let's add that to our regular polygon for our model. We have area is equal to n over 2 times the base times the apothem. And let's write that off on the side. A is equal to the apothem. All right, we might not always be able to, they might not always give us the apothem. And in that case, we have to do a little bit of extra work. And this is why I said it's not ideal to draw these shapes in your project. So let's say we have a hexagon now. It's a little bit easier for me to draw, I hope. Nope, because I went off the paper. We have this hexagon, and all we know is that the sides are 10, let's say centimeters. But we can start drawing, right? If we have a hexagon, that means we have 6 equal triangles, and each base is 10. So we have 6 triangles, each with a base of 10. So let's draw that triangle. Base of 10. But what we need to do is try to break this down even further to some triangles that we could figure out something about. So unfortunately, again, we would need to break this up into a smaller shape. And for that 1/2 of it, we have, right, in the big one, that's 10 centimeters, which means in the half of it, that would be 5 centimeters. But now we have that beautiful right angle, which means now we can do some trig. So again, we're going to take a step back, look at our whole shape. This is a hexagon. So we have 6 corners right up here. So this corner of the triangle would be 360, right? We can see, we go all the way around, divided by 6. So for here, that means 60 degrees. But that means this one is 30. And we want to figure out the apothem. So we have to rely back on our trig. And here we would have opposite and adjacent. So we would end up doing the tangent of 30 is equal to 5 over the apothem. Or we can do that switcheroo to get 5 over the tangent of 30. So unless we have the apothem already, we're going to have to do a little bit of work to actually find it. In this case, that means trig. So let's try that out. We do 5 divided by the tangent of 30 degrees, in which case we get A is approximately equal to 8.7. So now we have our apothem, so that means we can actually use our formula, which was the area of a regular polygon was n over 2 times the base times the apothem. So it's a hexagon, so n is 6, divided by 2 times the base, which was 10, and then times the apothem, which we said was about 8.7, right? So we can do that math a little bit before we plug it into the calculator. So then we do 3 times 10 times 8.7, and that would give us approximately, right, because we already rounded once, 261 square centimeters. So because we're trying to find the height of that triangle, we are going to have to use trig. But we do have a standard formula for this. Again, this is all optional because we don't need to be using this. Right? If we don't have the apothem, we can use some trick to figure it out. So let's rewrite that. We can say A for the apothem is equal to, and what we ended up doing, right, was our base divided by the tangent of 360 divided by n. Let me rewrite that because it's not looking too clear. So we had A is equal to, and we said our base divided by the tangent of 360 over n. All right, so that wraps up our unit. Again, in this optional video, if you wanted to find the area of a regular polygon, we can either measure or be given the apothem, or we have to use trig to find it, which is that last formula down there in regular polygon.